The universe is a story with entire chapters we can never read. We gaze at a starry sky and think of exploration. But what if some places are written in laws that forbid visitors? Today we are going on a journey to 25 of these permanently forbidden realms, from the crushing heart of black holes to the edge of reality itself. By the end, you will understand the fundamental limits that make most of the cosmos a locked book. We will see why the center of a black hole is a mathematical scream, and how entire epochs of time have vanished from our view. What does it mean for our curiosity that the universe keeps its greatest secrets under permanent lock and key? Our journey begins at the most absolute barrier in existence, a place where the concept of a place ceases to have meaning. This is the singularity at the heart of a black hole. Picture the event horizon as a one-way door, a point of no return from which not even light can escape. But that horizon is merely the lobby. The true mystery, the ultimate forbidden chamber, lies at the very center. According to the equations of Einstein's general relativity, all the matter that falls into a black hole is crushed by unimaginable gravity into a single point of infinite density. This is the singularity. Here, our understanding of reality shatters. The very fabric of space and time, the stage upon which the universe plays out, becomes so warped that it simply breaks. Our physics, which describes how matter and energy interact within space and time, has no language for a place where space and time do not exist. It is a mathematical scream, a division by zero in the cosmos. This creates profound puzzles like the information paradox. If you throw a book into a black hole, does the information within its pages simply vanish from the universe when the black hole eventually evaporates? That would violate a fundamental rule of quantum mechanics. Some theories, like the firewall hypothesis, suggest that the event horizon itself might be a raging wall of energy, destroying anything that crosses. But the truth is, we cannot know. The singularity is a permanent blind spot, a cosmic censorship that ensures no information, no signal, no story of what happens inside can ever reach the outside universe. It is the first and perhaps most famous of our forbidden regions, a reminder that some doors are locked not just by distance, but by the very laws of nature. That one-way door, the event horizon, is itself a region of profound impossibility. We call it a horizon because, like the point where the sea meets the sky, it marks the limit of what we can ever see. To understand why it is unbreakable, think of space as a flowing river and the black hole as a waterfall. The event horizon is the point where the current of space itself moves faster than the speed of light inward. Light, the fastest swimmer in the universe, struggles against this current. At the horizon, it is stuck, running in place. Past it, the current sweeps everything, including light, irrevocably over the edge. This is why crossing it is a one-way trip. There is no direction you can point your ship that leads outward, because all paths in space itself lead toward the crushing center. For an outside observer watching an object fall toward a black hole, something even stranger happens, a trick of relativity called time dilation. As the object approaches the event horizon from our perspective, its clock appears to slow down and slow down and slow down. It would seem to freeze, fading to a dim red glow as its light is stretched into longer, redder wavelengths. We would never, ever see it actually cross the line. It would simply appear to hover, a ghostly fossil etched onto the surface of the horizon for all eternity. The actual crossing, the final plunge, is an event forever hidden from our view. If we could somehow survive to approach this boundary, physics becomes a weapon. The force of gravity is so intense that it pulls much harder on your feet than on your head if you are falling feet first. This difference in pull, the tidal force, would stretch you into a long, thin strand of atoms, a process scientists grimly call spaghettification. Any probe, any structure, any form of matter would be shredded into a stream of elementary particles long before it reached the central mystery. This leads to a revolutionary and mind-bending idea, the holographic principle. It proposes that all the information about every star, every planet, every book that falls into a black hole is not lost inside. Instead, it is perfectly encoded like a cosmic barcode on the two-dimensional surface of the event horizon. The three-dimensional interior we imagine, with its mysterious depths and central singularity, might be a kind of illusion, a projection from the information painted on the surface. If true, the ultimate forbidden region is not a place you can visit at all, but a shadow play on a wall we can never touch. The horizon is not just a barrier, it is a cosmic prison wall, and the greatest jailbreak in the universe may be nothing more than a permanent, inescapable pattern of light and information. But what if the prison is not a black hole, but the entire universe itself? Beyond the crushing singularities and one-way horizons, there exists a much larger, and in some ways more profound, boundary. This is the cosmic horizon, the ultimate edge of everything we will ever be able to see. It is not a physical wall in space, but a wall in time. Think of the universe as an infinite dark ocean, and light is the messenger swimming toward us from distant shores. The Big Bang happened about 13.8 billion years ago. In all that time, light has had a finite period to travel. The cosmic horizon is simply the distance that the very first rays of light, emitted at the dawn of time, have finally managed to cross to reach our eyes today. Every star, every galaxy within that bubble is part of our observable universe. Everything outside it, however, is a different story entirely. The universe is not just expanding, it is accelerating. Distant galaxies are rushing away from us, and the farther away they are, the faster they recede. Beyond a certain point, they are moving away from us faster than the speed of light itself. Now, nothing can move through space faster than light, but space itself can stretch and expand at any rate. This means the light those ultra-distant galaxies emit is fighting a losing battle against the expanding fabric of the cosmos. It is like a swimmer trying to cross a river that is widening faster than they can swim. The light will never, ever reach us. Those regions are now causally disconnected from our pocket of reality. We are forever isolated from them. Over eons, this has a startling consequence. The galaxies we see today at the very edge of our vision will, one by one, cross over that horizon. Their light will stretch into invisibility, their signals will fade into silence, and they will vanish from our sky. Our cosmic map, our observable bubble, will actually shrink over time. Future astronomers in our galaxy, billions of years from now, will look up at a much darker, emptier sky. All the evidence for the Big Bang, all those distant galaxies, will have receded beyond the veil. They will see only the local group of galaxies forever bound together by gravity, adrift in an immense and impenetrable blackness. The universe outside our light cone is not just far away, it is a story whose pages we were only ever given a brief, introductory chapter. The rest of the book is flying away from us, unreadable, at speeds that make it permanently forbidden. That fading cosmic horizon leaves us isolated in a shrinking bubble, but there are places within our own galaxy that are just as permanently sealed. Take the collapsed heart of a giant star, a neutron star. If a black hole is a door slammed shut, a neutron star is a vault welded closed from the inside. These are the densest objects we can directly observe, the leftover cores of massive stars that exploded but were not quite heavy enough to collapse into a black hole. The forces at work here are almost beyond description. A single sugar cube of material from a neutron star would weigh about as much as Mount Everest. That density comes from a complete atomic breakdown. The immense gravity crushes atoms themselves, fusing protons and electrons together to form a solid sphere of neutrons, packed shoulder to shoulder with almost no empty space. This is matter in a state that simply cannot exist on Earth, but the surface, bizarre as it is just the shell. the true forbidden region is the interior. As you go deeper, the pressure climbs to levels that make our deepest ocean trenches seem like a calm pond. The neutrons are squeezed so tightly that they may dissolve into a swirling, frictionless sea, a superfluid. And at the very core, the pressure might be so unimaginably great that even neutrons themselves break apart into their constituent parts, a soup of quarks. This could be strange matter, a hypothetical state so stable it could convert any ordinary matter it touches. We simply do not know. Our equations of physics, which work well for stars and planets, break down under these extremes. We have models, educated guesses called equations of state, but they are just that, guesses. We cannot see inside. Any probe we could send would be instantly flattened into a thin film, then incorporated into the star's own structure, long before it sent back a single byte of data. Our only window into this vault comes from violent collisions. When two neutron stars spiral together and merge, they ring spacetime itself like a bell, sending out gravitational waves. By studying the subtle vibrations in these waves, astronomers can infer properties about the star's internal stiffness, offering indirect, tantalizing clues about the mysterious matter within. But a direct look, that is forever out of reach. The interior of a neutron star is a secret locked under a pressure so profound that the very act of trying to unlock it would destroy the key. The deepest vaults are not just places of immense pressure, but of profound darkness. There is an entire age of the universe, lasting for hundreds of millions of years, that is permanently veiled from our sight. This is the cosmic dark ages, the mysterious era between the fading of the Big Bang's first light and the dawn of the very first stars. To understand why this chapter is forbidden, we must rewind time. About 380,000 years after the Big Bang, the universe had cooled enough for a monumental change. Before this moment, it was a searing, opaque fog of charged particles and light, a plasma so thick that photons could not travel freely. Then, in an event called recombination, electrons settled into orbit around protons, forming the first atoms, mostly hydrogen. The universe suddenly became transparent. That first flash of clear light, stretched and cooled over billions of years of cosmic expansion, is what we detect today as the cosmic microwave background, our oldest baby picture of the cosmos. But after that flash faded into the expanding darkness, a long, quiet night began. The universe was a vast, featureless sea of neutral hydrogen gas, with no stars, no galaxies, and no new sources of light. It was quite literally a dark age. This is the forbidden region, not of space, but of time. Traditional telescopes are utterly powerless here. They collect light, but for all those millions of years, there was no light to collect. The neutral hydrogen gas that filled the cosmos acted like a cosmic sponge, absorbing any stray ultraviolet radiation that might have tried to pierce through. It was a universe in waiting, a canvas before the first brushstroke of starlight. Our only hope of mapping this hidden epoch is not with light, but with a whisper. Neutral hydrogen atoms have a very specific, faint radio signature, a signal emitted when the spin of an electron flips inside the atom. This creates a radio wave with a wavelength of 21 centimeters. In principle, that faint radio echo from the primordial hydrogen of the Dark Ages still washes over us, stretched and distorted by the expansion of the universe. Catching it is one of the greatest challenges in modern astronomy. It is an incredibly weak signal buried under a cacophony of radio noise from our own galaxy and civilization. Projects are underway to build vast, quiet radio telescopes in remote locations, hoping to tune into this ancient static and create a shadowy, indirect map of the universe before the first dawn. But a direct view, a true photograph of that dark, formless time, that is impossible. The era produced no light to carry an image to us. It is a silent gap in the cosmic record, a blank page in the story of everything, forever lost to the relentless forward march of time. That silent, dark age of the universe stands in stark contrast to the violent, swirling chaos of a place much closer to home, yet just as permanently hidden from our direct view. Deep within our own solar system, beneath the beautiful, banded clouds of Jupiter, lies another impenetrable realm. The journey to the core of a gas giant is a descent into a world of escalating impossibility. Imagine starting at the cloud tops, those familiar stripes of ammonia ice and water vapor. As you plunge downward, the light fades rapidly. The gentle, cold winds at the surface give way to howling jet streams and storms that have raged for centuries, like the Great Red Spot. The pressure builds with every kilometer, squeezing the hydrogen gas that makes up most of the planet into forms that defy earthly experience. About 10% of the way down, the pressure becomes so immense, over 1 million times Earth's atmospheric pressure, that something extraordinary happens. The hydrogen, normally a transparent gas, is compressed into a liquid, but this is no ordinary liquid. It begins to act like a metal. The electrons are squeezed right off their parent atoms, creating a searing, electrically conductive ocean of protons and free-flowing electrons. This is metallic hydrogen, a state of matter we cannot create and sustain in any laboratory on Earth. It is theorized to be the source of Jupiter's incredibly powerful magnetic field, a dynamo churning deep within the planet's interior. This metallic ocean is thought to extend downward for tens of thousands of kilometers, a realm of perpetual, pitch-black twilight and pressures that crush matter into alien forms. What lies at the very center after this endless descent through liquid and metallic hydrogen is one of solar system's great enduring mysteries. Most planetary scientists believe there is a core. Not the small, dense seed the planet may have formed around, but something larger, a compact ball of rock and metal, perhaps 10 to 20 times the mass of Earth, stewing under temperatures hotter than the surface of the Sun and pressures beyond comprehension. But is it a solid sphere of iron and silicate rock? Is it partially dissolved, mixing with the metallic hydrogen above it in a strange, fuzzy boundary? We simply do not know. The entire planet is a perfect shield. Those beautiful, turbulent clouds are an opaque, violent blanket thousands of kilometers thick. Our eyes and our telescopes are utterly blind to what lies beneath. We have sent probes like Galileo and Juno into the system. Juno, with its precise gravity science measurements, can map the planet's inner structure by feeling the subtle tugs and pushes on its orbit, creating a rough density map. It is like trying to deduce the shape and size of a stone at the bottom of a deep, raging whirlpool by only studying the swirls on the surface. Any attempt at a direct mission is a fantasy of destruction. A probe, no matter how robust, would be crushed by the overwhelming pressure, melted by the extreme heat, and then completely vaporized and assimilated into the planet's interior long before it ever got close to the mysterious core. Jupiter's heart is a secret locked inside a fortress of storm, pressure, and exotic matter, a forbidden region right in our cosmic backyard. Jupiter's violent, hidden heart is at least anchored to a star, a source of light and energy. But some worlds are cast out entirely, sentenced to an eternal exile in the cold, silent dark between the stars. These are rogue planets, and their surfaces represent a different kind of forbidden realm, one defined by absolute isolation. Imagine a world like Earth or a gas giant like Neptune, violently flung from its young star system by gravitational encounters. It is set adrift, a cosmic castaway. The journey to its surface begins not with an approach to a sun, but with a descent into an abyss of black. With no host star, the sky is forever starless on the day side, a perfect void punctuated only by the distant, unmoving pinpricks of galaxies. The surface temperature plummets to just a few degrees above absolute zero. Any atmosphere it once possessed would have long ago frozen solid, falling as snows of nitrogen, oxygen, or methane, creating a barren, airless landscape of ice over rock. It is a perpetual, deep freeze night, a silence so complete it is deafening. The very challenge of finding such a world highlights its forbidden nature. These planets emit no light of their own and reflect none. They are dark ghosts drifting through the interstellar void. We can only detect the very largest of them, and only if they pass directly in front of a distant background star, their gravity briefly bending and magnifying the star's light in a phenomenon called gravitational microlensing. It is a fleeting, 1 in a billion chance alignment. Even if we pinpointed one, the distance is staggering. The closest rogue planet is likely tens of trillions of miles away, a journey that would take tens of thousands of years with our current technology. There is a haunting theoretical possibility, however. For a rocky rogue planet with a radioactive heart, internal geothermal heat could maintain a vast global ocean of liquid water beneath a thick, insulating shell of ice. In that lightless, pressurized sea, completely cut off from the universe above, who knows what chemistry or even what slow, cold biology might persist. But it is a secret locked inside a frozen tomb, adrift in an ocean of emptiness. To visit would require a ship capable of a multi-millennial voyage with no solar power, navigating the featureless dark toward a target that gives off no signal. The surface of a rogue planet is not forbidden by crushing gravity or fiery pressure, but by the sheer, soul-crushing scale of the void itself, a loneliness so profound it becomes a prison wall. The profound loneliness of a rogue planet is a silence imposed by distance, but some theoretical realms are forbidden by the very direction of time itself. This brings us to one of the most speculative ideas in all of cosmology, the white hole. If a black hole is a cosmic drain from which nothing can escape, a white hole would be its exact opposite in time, a cosmic fountain from which nothing can enter. Picture a region of spacetime that violently expels matter and energy, but has an event horizon that acts as a perfect one-way exit door. Anything can come out, but nothing, not even light, can ever go in. The mathematics of Einstein's general relativity are symmetrical, and they allow for such a bizarre solution. A white hole is essentially a black hole running in reverse. While a black hole's formation is a catastrophic collapse, a white hole would be a sudden, explosive appearance of matter from a singular point. The problem is, this reversal seems to violate the second law of thermodynamics, the universal rule that disorder always increases. A white hole would appear to be creating order from nothing, which makes most physicists deeply skeptical of their actual existence in our universe. They are a fascinating what-if on paper, but not something we expect to find. Yet, the idea is tantalizingly linked to other cosmic mysteries. One compelling, though purely theoretical, notion is that a white hole could be the other end of a black hole, connected by an Einstein-Rosen bridge commonly called a wormhole. In this scenario, matter falling into a black hole might not be crushed at a singularity, but instead be spewed out, unharmed, from a white hole in another part of the universe or even another time entirely. It paints a picture of a cosmic subway system, with black holes as the entrance tunnels and white holes as the exits. But here is the ultimate catch that seals this region as forever forbidden. Even if a white hole did exist, its fundamental nature makes it just as inaccessible as the heart of a black hole. You cannot approach it, study it from the inside, or send a probe through its horizon, because that horizon repels all inward travel with absolute finality. You could only ever observe it from the outside, watching as it violently burps up streams of primordial matter. Any attempt to cross its threshold would be like trying to walk into the jet of a fire hose pushing outward at the speed of light, an impossibility. So whether it is a mathematical curiosity or a hidden half of a wormhole, the interior of a white hole remains a realm permanently locked behind a one-way sign that reads "exit only," a theoretical place where the universe itself seems to scream "keep out." The white hole's one-way exit is a cosmic oddity, but to find a truly fundamental lock on reality, we must shrink our perspective to the very limits of existence. This is the quantum foam at the Planck scale. If we could zoom in on the fabric of spacetime itself, past atoms, past protons and neutrons, down to scales a billion times smaller than an atomic nucleus, our smooth, continuous universe would vanish. In its place, we would find a seething, turbulent chaos. This is not empty space. According to the principles of quantum mechanics, the void is alive with violent, fleeting activity. At this unimaginably tiny scale, spacetime itself is theorized to lose all smoothness. It churns and froths like the surface of a stormy ocean at the molecular level. This is the quantum foam. Here, the very concepts of here and now break down. Tiny wormholes and bridges in spacetime are thought to blink into and out of existence in less than an instant. Pairs of virtual particles, matter and antimatter, spontaneously erupt from the energy of the vacuum before annihilating each other almost immediately. It is a realm of constant, frantic creation and destruction, the foundational noise from which all reality emerges. The energy required to probe this scale, to take a picture of this foam, is staggering. It is called the Planck energy, a level of concentrated power not seen since the first fleeting moments of the Big Bang itself. To achieve it with a particle accelerator, we would need a machine larger than our entire galaxy. This makes it not just a technological challenge, but a potentially permanent barrier. More profoundly, the act of measurement itself may be fundamentally impossible. To observe something this small, you must strike it with a particle of incredibly high energy. But that very act, that photon or particle you use to see, would deliver so much concentrated force it would violently churn the foam you are trying to study. It is like trying to map the delicate patterns of soap bubbles by hitting them with a sledgehammer. You would not see the foam, you would only see the aftermath of your own destructive probe. This scale is the final frontier where our two great theories of reality, Einstein's smooth spacetime of general relativity and the chaotic, probabilistic world of quantum mechanics, collide and fail. To understand the foam is to have a theory of quantum gravity, a unified description of the cosmos at its most basic level. Yet the quantum foam suggests that this deepest layer of reality may be inherently unobservable, a permanently forbidden region, not because it is far away, but because it is too small and too fragile for us to ever see without destroying it in the process. The bedrock of the universe may be a secret it is physically structured to keep. The quantum foam's chaotic dance is a secret held at the smallest scales, but our own solar system guards a forbidden region of staggering emptiness at its very edge. This is the Oort cloud, the final frontier of our sun's gravitational influence, a vast and silent reservoir of ancient ice. Picture the solar system not as a flat disk ending with Pluto, but as a nested structure. Inside, you have the rocky planets, then the asteroid belt, followed by the gas giants, and finally the Kuiper belt, a donut of icy bodies where Pluto resides. But beyond all that, starting about 2,000 times farther from the Sun than Earth, and extending outward for perhaps a light year or more, lies a spherical shell of frozen debris. This is the Oort cloud, a graveyard of primordial material left over from the solar system's birth. Its scale is almost incomprehensible. It is thought to contain trillions of icy nuclei, the dormant hearts of comets, but they are scattered across such an immense volume of space that the average distance between them could be measured in millions of miles. A spacecraft passing through this region would likely see nothing but black, empty space for centuries. It is a place of profound isolation, where the sun is reduced to little more than the brightest star in a sea of stars, offering no warmth, only a faint guiding light. The journey to even the inner fringes of this cloud with our current technology is a sobering exercise in patience. Using the most powerful chemical rockets we have, a one-way trip would take tens of thousands of years. It is a timescale that dwarfs human civilization, making it a voyage of pure theory, not of practical exploration. In fact, the Oort cloud itself remains a brilliant deduction, not a confirmed observation. We have never seen it directly. Its existence is inferred from the behavior of long-period comets, those rare, spectacular visitors that take thousands or even millions of years to complete a single orbit. Their paths suggest they originate from this distant spherical shell, gently nudged by the gravity of passing stars or galactic tides to begin their long fall toward the inner solar system. This diffuse nature is what makes the Oort cloud a permanently forbidden region for targeted study. We cannot aim a telescope at a specific spot and see its structure. We cannot plot a course to a known major object within it. Any mission would be a shot in the dark, a desperate hope to encounter one of its trillions of invisible, drifting snowballs in a cosmic ocean of nothing. It is the ultimate borderland of our solar system, a place so vast and empty that it defines the very limits of our reach, a frozen archive of our beginnings that we can only ever know from the rare messengers it sends our way. The frozen archives of the Oort cloud are a testament to our own beginnings, but what if the universe offered a shortcut through such immense distances? This brings us to the ultimate cosmic tunnel, a wormhole. In science fiction, these are the gateways that connect distant parts of the galaxy in an instant. In reality, they are a tantalizing maybe written into Einstein's equations. The math of general relativity allows for bridges in spacetime, shortcuts that could theoretically connect two distant points by bending the fabric of the universe into a tunnel. This tunnel or throat would be the interior of the wormhole, and it represents a hypothetical forbidden region of a very different kind. It is not forbidden by distance or destruction, but by the sheer instability of its own existence. The problem is one of architecture. A natural wormhole, if one could form, would be incredibly unstable. The moment it opened, the immense gravity of the tunnel itself would cause it to pinch shut faster than light could travel through it, collapsing the shortcut before anything could use it. To prop it open, to make it traversable, you would need a scaffolding of something truly bizarre, exotic matter. This is not just strange matter like inside a neutron star, but matter with a property that seems to defy common sense, negative energy density. Think of it as a kind of anti-gravity lining for the tunnel, something that repels the walls and keeps them from collapsing. While quantum mechanics allows for tiny amounts of negative energy in specific circumstances, like the Casimir effect between two metal plates, the amounts needed to stabilize a wormhole large enough for a person are astronomical and may be completely impossible. Even if we somehow line the tunnel with this exotic material, the journey through the throat would be no gentle ride. The geometry inside would be profoundly alien. You might look ahead and see a distorted image of your destination star, while looking behind, you see a warped view of your point of origin, both images wrapped around you in a disorienting sphere of light. And while the exotic matter might counteract the crushing gravitational collapse, there is no guarantee it would negate the tidal forces, the stretching pull of gravity. You could still be spaghettified, stretched into atoms by the strange curvature of the tunnel itself. The greatest unknown, however, lies at the end of the trip. Let us say you built it, you lined it, and you stepped in. The interior of that wormhole is a realm of pure theory until someone actually traverses it. Is the other end where you think it is? Has it remained stable, or did it shift? Is the exit hovering safely in space, or has it deposited you inside a star, or a black hole, or a completely different universe? There is no way to send a probe ahead to check, because the act of sending the probe is the traversal. The first trip is a leap of faith into a one-way corridor where the laws of physics as we know them are being forced into an artificial shape. Until a conscious being or a very brave robot makes that irreversible journey and sends a signal back. If a signal can even be sent back, the interior of a traversable wormhole remains the ultimate locked room mystery. It is a door we might one day build, but we could never know what is on the other side until we close it behind us forever. a wormhole's eggs, it might open onto a world of impossible weight. Super-Earths, planets several times more massive than our own, promise landscapes of crushing majesty and interiors locked away by pure physics. These are not simply larger versions of Earth. Their increased mass creates a gravitational grip so strong that a simple walk would feel like carrying a car on your back. But the true forbidden realm lies beneath any hypothetical mountain range deep within the planet itself. The journey to the core of a super-Earth is a descent into a pressure cooker of planetary scale. Start at the surface. The atmosphere, if one exists, would be profoundly thick and heavy, pressing down with thousands of times the force of our own air. Any craft attempting to land would face a blistering entry, followed by the relentless squeeze of this dense shroud long before it ever touched ground. But passing through that atmosphere is merely the first door. Below the surface, the real trial begins. With every kilometer downward, the pressure from the overlying rock climbs at a terrifying rate. Temperatures soar from internal heat and radioactive decay. Long before reaching the halfway point, pressures would exceed 1,000,000 times Earth's surface pressure, and temperatures could rival the Sun's surface. In this hellish environment, matter is forced into states we can only simulate in supercomputer models. Water, for instance, would not simply be a liquid or a vapor. It could become superionic ice, a bizarre, black material where oxygen atoms are locked in a crystalline lattice while hydrogen ions flow through it like a liquid metal, making it both a solid and an electrical conductor at the same time. In carbon-rich super-Earths, the pressure might be so immense that it crushes carbon into vast planetary-scale layers of diamond, sinking through molten rock toward the core. The very mantle, the thick layer of rock beneath the crust, might not be solid as we know it. Under such extremes, silicate minerals could take on exotic, high-pressure forms with strange names like post-perovskite, or even become electrically conductive, blurring the line between rock and metal. The core itself is a mystery wrapped in an enigma. Is it a gargantuan ball of solid iron, even larger than Earth's entire core? Or does the incredible pressure create new, unknown phases of iron crystal, or even a soup of free-flowing nuclei? We have no way to know for sure. Our most robust deep Earth probes on our own planet, like submersibles built to explore the Mariana Trench, would be instantly crumpled into a speck on a super-Earth. All known materials, from titanium to diamond, would melt, deform, or simply flow like liquid under such conditions. There is no drill bit, no sensor, no vessel we could conceive of that could survive the journey to return data. Furthermore, the immense gravity creates a second, equally daunting barrier: escape velocity. The energy required to launch from the surface of a super-Earth and achieve orbit is exponentially greater than from Earth. A rocket that could land there might be forever trapped, unable to muster the thrust to leave. This means any direct mission, even a one-way probe, becomes a monumentally difficult prospect of delivering a lander robust enough to withstand the descent and the environment with no hope of return. The deep interior of a super-Earth is thus doubly forbidden, sealed by an environment that destroys all known technology and a gravity well that could become a permanent planetary prison. These worlds are cosmic fortresses, their greatest secrets guarded by the very forces that give them form. The crushing gravity of a super-Earth is a planetary prison, but some worlds are sentenced to a different kind of hell, one of relentless stellar fury. Orbiting closer to their stars than Mercury is to our Sun, hot Jupiters are cosmic anomalies, gas giants forged in a furnace. Their atmospheres are not just hostile, they are realms of pure elemental violence. Imagine a place where the very concept of day and night is warped by tidal locking. One side of the planet, the day side, is perpetually blasted by its star, heated to temperatures that can soar above 2,000 degrees Celsius, hot enough to vaporize iron. The night side, forever turned away, is a comparatively cooler but still scorching abyss. This extreme temperature difference from stellar inferno to eternal twilight doesn't create a gentle breeze. It fuels permanent planet-spanning hurricanes. Winds scream across the terminator line between light and dark at speeds exceeding 5,000 miles per hour, far faster than the speed of sound on Earth, carrying with them a rain of nightmares. At these temperatures, the clouds are not made of water vapor, but of vaporized rock and metal. Silicate minerals and even titanium oxide can condense out of the searing air on the cooler night side, only to be swept back into the dayside furnace by those supersonic winds, creating a global downpour of molten rock and liquid metal. We know these details not from visiting, but from the ghostly fingerprints of light. Using a technique called transmission spectroscopy, astronomers watch as the planet passes in front of its star. The star's light filters through the thin outer layers of the planet's atmosphere, and different gases absorb specific colors. By analyzing the missing colors in the starlight, we can detect the chemical signatures of sodium, potassium, water vapor, and even those exotic metal oxides. It is like diagnosing a fever by studying the shadow a person casts, but sending a probe into this maelstrom is a fantasy of destruction. The first hurdle is the star itself. Orbiting so close, the planet is bathed in intense X-ray and ultraviolet radiation that would fry the electronics of any spacecraft long before it arrived. Then comes the gravitational tug of war. The star's immense gravity creates powerful tidal forces, stretching and squeezing the planet, and any probe that approaches would be subjected to the same violent stresses, risking being torn apart. If a craft could somehow survive to enter the atmosphere, its fate is sealed. The combination of extreme heat, corrosive chemical soup, and pressures thousands of times greater than Earth's would incinerate and crush it within seconds. Even if it were built from some miraculous material, the communication problem is insurmountable. To send data back to us, the probe would need to point its antenna precisely at Earth while being tossed in supersonic winds and cooked from all sides. The signal would be weak, drowned out by the radio noise of the nearby star, and ultimately the planet's gravity, combined with the drag of the thick, violent atmosphere, would inevitably pull the probe down, dragging it into deeper, hotter layers until it is vaporized and assimilated into the planet's own hellish weather patterns. The atmosphere of a hot Jupiter is a permanent storm of fire and metal, a place where we can read the chemical poetry from a safe distance, but whose visceral, terrifying reality is forever locked behind a curtain of radiation and flame. A pulsar's furious energy makes a hot Jupiter seem almost tranquil. This is a neutron star that did not go quietly into the cosmic night. Instead, it spins, often hundreds of times per second, and with each rotation, it sweeps the universe with beams of radiation more powerful than any weapon we could conceive. To approach one is to fly into the path of a cosmic lighthouse whose light is pure annihilation. The beams are not mere light, but focused torrents of X-rays and gamma rays, generated by a magnetic field so strong it defies reason, trillions of times more powerful than Earth. From a distance greater than that between the Earth and the Moon, this radiation would be instantly fatal to any astronaut and would reduce a spacecraft's delicate electronics to useless, fried silicon in a heartbeat. There is no shielding thick enough, no material resilient enough to withstand that directed, pulsating fury for more than a fleeting moment. It is a permanent, rotating kill zone that makes close observation a suicide mission. If you could somehow magically survive to see the surface, you would find a landscape of impossible physics. The crust, if we can call it that, is not rock. It is likely a crystalline lattice of iron nuclei, a metal mountain range forged under pressures that make diamonds seem soft as butter, and yet these mountains are not towering peaks. The star's immense gravity, 100 billion times stronger than Earth's, is so overpowering that it crushes any irregularity flat. The tallest mountain on a pulsar might be a mere millimeter high, a subatomic wrinkle on an otherwise perfectly smooth, impossibly dense sphere. Landing on such a surface is a paradox of its own. The gravity is so intense that any object, any probe, would be pulled in with catastrophic force. The impact would not be a gentle touchdown, but a release of energy equivalent to a thermonuclear bomb, all focused on a tiny point. The probe would be vaporized, its atoms fused into the pulsar's own crystalline crust in a flash. And even if you could land without destroying yourself, you would face the star's rotation. A pulsar spinning hundreds of times per second has an equatorial surface moving at a significant fraction of the speed of light. Any structure, any instrument, would be subjected to centrifugal forces that would rip apart molecular bonds, tearing matter apart from the inside out. The surface of a pulsar is a place where the very laws of physics conspire to forbid presence. It is a realm of lethal light, crushing flatness, and relativistic spin, a dynamo of pure cosmic power where the universe screams a permanent and absolute no entry. From the furious light of a pulsar, we step into the profound opposite, an emptiness so vast it defies human intuition. The Boötes void is one of the largest known structures in the universe, a spherical region of space roughly 330 million light-years across, and it contains almost nothing. While most of the cosmos is arranged in a great cosmic web of galaxy clusters and filaments, the Boötes void is a gaping hole in that web, a bubble in the foam of creation where the universe forgot to put galaxies. In a volume of space that could comfortably hold tens of thousands of galaxies like our Milky Way, astronomers have found only a few dozen, scattered like lonely islands in an ocean of black. The mystery of its existence is a deep cosmological puzzle. Is it simply a statistical fluke, a rare but natural empty patch in the grand tapestry? Or could it be evidence of something more exotic, like the imprint of a collision with another universe in the multiverse, or the work of forces we do not yet understand? For now, it remains one of the universe's great blank spots. We can observe its emptiness from the outside, mapping the few galaxies within it and charting the stark boundaries where the cosmic web resumes. But to truly explore the void, to travel into its heart, is to confront a different kind of forbidden realm. It is not forbidden by crushing gravity or searing radiation, but by the sheer, soul-crushing scale of nothingness. Imagine a spacecraft somehow capable of interstellar travel, setting a course for the center of the Boötes void. The journey to its edge would already be an epic spanning millions of years. But crossing the void itself would be an experience of profound isolation unlike any other. As you leave the last outlying galaxies behind, the stars would thin and then vanish. The viewports would show only an unbroken, perfect black. There would be no stars for navigation, no nearby planets for resources, no light for solar power. You would be adrift in a featureless sea with no landmarks for millions of years. The cosmic microwave background, the faint afterglow of the Big Bang, would be your only constant companion, a uniform glow in all directions offering no sense of motion or progress. This is not just a practical barrier, it is an existential one. Without the gravitational tug of stars and galaxies, course corrections would become incredibly difficult. Any failure, any need for repair or resupply could not be addressed by visiting a nearby system because there are none. The void is a practical and psychological prison. A mission into it would be a one-way trip into a sensory deprivation tank on a cosmic scale, with the crew, or their robotic successors, utterly alone for timeframes that dwarf human history. Even if we could build a ship that lasted that long, the act of exploration loses meaning when there is literally nothing to see or interact with for epoch upon epoch. The Boötes void is thus a forbidden region defined by absence. It is a reminder that the universe is not just full of violent, energetic places we cannot visit, but also of immense, quiet empties we cannot bear to cross. Its exploration is not blocked by a wall of fire, but by an ocean of night so deep and so wide that the very concept of a journey dissolves into the endless dark. The Boötes void is a profound emptiness, a blank page in the present. But there is a chapter from the very first moment of creation that is even more fundamentally sealed from our view. This is the inflationary epoch, a sliver of time so brief it defies comprehension, yet it shaped everything that followed. To understand this forbidden region, we must rewind the cosmic clock to a mere fraction of a second after the Big Bang. At this instant, the universe was unimaginably hot, dense, and chaotic. Then, according to our leading theory, something extraordinary was triggered. A strange field of energy, known as the inflaton field, dominated the cosmos. This field possessed a peculiar property. It created a kind of repulsive gravity, causing spacetime itself to stretch at an exponential, staggering rate. The universe did not just expand, it inflated, doubling in size over and over again, faster than the speed of light. In less time than it takes to blink, a subatomic speck of primordial reality ballooned to a size larger than our entire observable universe today. This violent, faster-than-light stretching performed two crucial acts of cosmic surgery. First, it ironed out any wrinkles or irregularities, explaining why the cosmos appears so remarkably flat and smooth on the largest scales. Second, it took tiny quantum fluctuations, the jittering froth from the Planck scale, and stretched them to astronomical sizes. These stretched ripples in the fabric of spacetime became the seeds for all future structure, the gravitational blueprints for galaxies, clusters, and the great cosmic web. We cannot see this era directly. No light, no signal, no messenger from that time could possibly survive or reach us. The universe was an opaque, searing plasma. Our only evidence is the ghostly imprint it left behind, like a fossil pressed into clay. That clay is the cosmic microwave background, the afterglow of the Big Bang released 380,000 years later. The subtle patterns of hot and cold spots in that microwave light, mapped with exquisite precision by satellites, match the predictions of inflationary theory perfectly. They are the amplified echoes of those primordial quantum jitters. To directly probe the inflationary epoch, however, is an impossibility of a different order. The energy scales at work during inflation represent the ultimate high-energy frontier. It was a time when the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were unified into a single, pristine superforce. To recreate those conditions, to peer back into that moment, we would need a particle accelerator of mind-boggling scale. The energies required are a quintillion times greater than what our most powerful machine, the Large Hadron Collider, can achieve. Building such an accelerator is not just an engineering challenge, it is a cosmic one. Theoretical calculations suggest the machine would need to be roughly the size of our entire galaxy. It is a project forever beyond the reach of any civilization, bound by the laws of physics and the practical limits of matter and energy. The inflationary epoch is thus a permanently forbidden region in time. We can deduce its history from the cosmic fingerprints it left, but we can never witness its furious, universe-forging events directly. It is the ultimate locked room at the beginning of everything, a door sealed not by distance, but by the unimaginable energy of creation itself. The furious energy of creation forged the universe, but some of its most profound secrets now lie frozen and silent. On the icy moon Europa, a forbidden ocean churns in perpetual darkness, and its deepest secret is not the water itself, but what lies at the very bottom. Beneath a shell of ice many kilometers thick, a global saltwater ocean perhaps twice the volume of Earth's own seas is kept liquid by the relentless gravitational kneading from Jupiter. While future missions dream of tasting that water, the ultimate prize and the ultimate challenge lies far below. This is the ocean floor of Europa, a landscape we have never seen, sculpted by forces we can barely imagine. It is a place where alien geology and the potential for life intertwine in a realm of crushing pressure and eternal night. The journey to reach it is a sequence of daunting, perhaps impossible, gates. First, you must penetrate the icy crust. This is not a simple layer of frost. It is a geological puzzle, a shell of water ice that could be 15 to 25 kilometers thick, laced with fractures and potentially unstable. To reach the ocean, you would need a robotic drill or a nuclear-powered thermal probe, a device capable of melting its way down through this immense frozen barrier. The process would take months, if not years, all while the surface above is bathed in lethal radiation from Jupiter's magnetic field, frying unprotected electronics. Finally, your probe breaks through into the abyss. It is now suspended in a world of absolute blackness under a ceiling of ice. The water here is cold, near freezing, but it is under immense pressure from the weight of the ice above. Your craft must now become a submersible, built to withstand the deep sea pressures while navigating blindly through a pitch-black void with no sunlight to guide it. Its mission, to descend perhaps another 100 kilometers to the seafloor. This is where the true mystery unfolds. Scientists strongly suspect that Europa's rocky seafloor is geologically active, heated by the same tidal forces that flex the Moon's interior. On Earth, in our own deep ocean trenches, such heat gives rise to hydrothermal vents, cracks in the seafloor that spew superheated, mineral-rich water. These vents are oases of life, entire ecosystems that thrive not on sunlight but on chemical energy. On Europa, such vents could exist, providing the warmth, energy, and chemistry needed to sustain life completely independent of the sun. The seafloor could be a tapestry of volcanic ridges, strange mineral chimneys, and warm, habitable pockets. But exploring it is a monumental task. The submersible must operate autonomously in the darkness, mapping with sonar and sampling with robotic arms, all while battling the intense pressure that seeks to crush it. And then comes the final, critical challenge: communication. How do you send the data back to Earth? A cable trailing back up through the ice hole is impractical over such distances and through a shifting ice sheet. The submersible would likely need to store its precious data, then attempt a perilous ascent back to the underside of the ice, find its original entry point or a pre-deployed receiver, and transmit its findings through the ice to an orbiter and then across the gulf of space to us. Each step is a potential point of catastrophic failure. While upcoming missions like NASA Europa Clipper will fly by and study the Moon from orbit, and concepts for landers and ice penetrators are being drawn, a mission to the seafloor itself is a challenge for the distant future. It requires a suite of technologies that do not yet exist, working in flawless harmony in the most hostile environment we can attempt to reach. The ocean floor of Europa is a forbidden region not by the laws of physics, but by the staggering magnitude of engineering it demands. It is a dark, silent world that may hold the answer to whether we are alone in the cosmos, an answer locked under a sky of ice and guarded by an abyss of cold, black water. Europa's hidden ocean is a secret within our own solar system, but what if our entire cosmos is just one room in an infinite mansion? This brings us to one of the most speculative frontiers in all of thought, the regions beyond our universe, the space between bubbles in a possible multiverse. The idea stems from a tweak to cosmic inflation, the theory of the universe's explosive initial growth. In a model called eternal inflation, that repulsive energy field never completely shuts off. Instead, it decays in random patches like a pot of boiling water. Each place where the energy drops forms a bubble of stable spacetime, a new universe with its own laws of physics, inflating within the greater, still inflating background. Our entire cosmos, with all its galaxies and stars, could be one such bubble in a frothing, endless sea of creation. So what lies in the gaps between these bubbles? The answer is as strange as it is definitive. That space is not space as we know it. It is the still inflating background, often called the false vacuum, a realm where the inflattened field is still energized and space-time is stretching at an incomprehensible rate. It is a kind of cosmic superhighway being paved faster than anything could ever hope to travel on it. The boundary of our bubble universe, our local region of stable physics, is a wall of energy, a domain wall expanding at nearly the speed of light. Nothing from inside our bubble, no particle, no light ray, no information of any kind can ever cross that wall into the inflating background. To do so would require moving faster than light, which is impossible within our local laws. Even more fundamentally, the outside may not even have the same dimensions of time. Causality, the rule that cause must precede effect, might not apply there. This makes the interbubble regions not just physically unreachable, but fundamentally inconceivable. They exist in a framework completely disconnected from our continuum of space and time. We could never send a probe because the probe itself is made of the matter and forces defined inside our bubble. It has no existence or meaning on the other side of that wall. This places the multiverse and its gaps squarely in the realm of theoretical physics, not future exploration. It is a mathematical possibility, an elegant explanation for why our universe has its specific, life-permitting constants, but it is ultimately untestable by any experiment we can devise from within our cosmic room. The regions beyond the multiverse represent the ultimate forbidden frontier, defined not by distance or danger, but by the simple, absolute fact that for us there is no beyond. Our physics, our reality, our very story ends at the bubble's edge. Our bubble universe defines the edge of everything we can ever know, but what about cracks in the fabric of that bubble itself? This brings us to cosmic strings, hypothetical scars from the universe's violent birth. If they exist, they are not objects in space, but flaws in spacetime, one-dimensional defects frozen into the structure of reality when the fundamental forces of nature split apart during the cosmic cooling after the Big Bang. Think of it like this: when water freezes into ice, bubbles and cracks can get trapped inside. A cosmic string would be a similar crack, but in the very fabric of the cosmos. The scale is mind-warping. A cosmic string would be thinner than a single atom, yet it would possess an almost unimaginable density. A single inch of it could contain the mass of an entire mountain range. This creates a gravitational footprint like nothing else. Space around a cosmic string would be severely warped. If one were to pass near Earth, we would not feel a pull but a bizarre optical effect. Because the string warps spacetime so severely, light from objects behind it would be split, creating a double image of a distant star or galaxy, a perfect cosmic mirage with no lens in between. But the true mystery, the forbidden region, is not the space around the string, but the string itself. What is inside it? Does it even have an interior? The mathematics suggest it is a line of concentrated energy, a flaw so fundamental that the usual rules of matter and space break down within its infinitesimal width. It might be a tunnel into a different state of vacuum energy, a place where the laws of physics are those of the universe's earliest, hottest moments, preserved in a thread thinner than anything we can measure. Trying to study that interior is an exercise in profound impossibility. First, we have never definitively observed one. Their predicted signatures, like those double images of galaxies or distinct ripples in the cosmic microwave background, have not been conclusively found. They are ghosts in the equations. Second, if they do exist, models suggest they would not be stationary. They would likely be moving at a significant fraction of the speed of light, whipping through the cosmos in vast, vibrating loops. Simply finding one would be a monumental challenge of celestial timing, but to probe its interior, you would need to intersect its path. Given its theoretical width is smaller than a proton, hitting it would be like trying to shoot a single, specific atom in another galaxy with a rifle from Earth. Even if you could orchestrate that impossible collision, the encounter would be catastrophic. An object with the linear density of a mountain range per inch, moving at relativistic speeds, would slice through any probe, any planet, any star like a hyperdimensional wire through cheese. The gravitational shockwave and radiation released would be apocalyptic. There would be no sampling, no gentle analysis. The act of touching a cosmic string would be an event of total destruction, obliterating the very instrument sent to study it. So the interior of a cosmic string remains a double-locked secret, first by its likely non-existence, and second by the sheer physical violence that any attempt to breach it would entail. It is a crack in reality so sharp and so dense that looking inside may be synonymous with annihilation. A cosmic string would slice through worlds, but there is a planet in our own neighborhood where the surface itself is a slow, corrosive blade. Venus, our so-called sister planet, hides a surface that is the very definition of a forbidden landscape. While a handful of Soviet Venera probes managed to land and transmit data for mere minutes in the 1970s and 80s, those were acts of heroic suicide. Sustained exploration of that world is a dream crushed by physics. The numbers alone tell a story of impossibility. The surface temperature is a constant 460 degrees Celsius, over 860 degrees Fahrenheit, hot enough to melt lead and zinc. The atmospheric pressure is 92 times that of Earth, a crushing force equivalent to the weight found 900 meters beneath our ocean waves. And the sky is not a sky of air, but a perpetual toxic haze of carbon dioxide with clouds of sulfuric acid that rain acid droplets which evaporate long before they hit the scorching ground. This combination creates an environment that is not just hostile but actively, aggressively destructive. It is a corrosive, superheated pressure cooker. Modern electronics, the delicate silicon brains of any robotic explorer, would be cooked in moments. Metals would not just weaken, they would chemically react with the sulfurous atmosphere. The very lenses of cameras would be clouded and etched by acid. A lander would not simply stop working, it would be dissolved and crushed simultaneously. This is why concepts for Venus exploration sound like science fiction. Engineers dream of landers built like deep-sea submarines with pressure hulls of titanium or beryllium, powered by turbines turned by the howling winds and filled with electronics encased in refrigerated, pressure-sealed chambers. These are machines that would have to be more robust than any rover sent to Mars, designed for a lifespan measured in hours, not years. An even more tantalizing idea is to abandon the surface entirely and aim for the upper atmosphere. About 50 kilometers up, the pressure and temperature are remarkably Earth-like. Here, concepts for floating cities, vast dirigibles filled with breathable air, could theoretically drift in the milder winds, studying the planet from above. But this only highlights the true forbidden nature of the surface itself. All that fascinating geology, the volcanic plains, the tessera highlands that might be continents of a bygone era, the mysterious signs of possible recent lava flows, all of it remains locked away. To roll a rover across that terrain, to drill into a rock, to conduct long-term seismic studies to understand the planet's heart, these are feats that demand a presence on the ground. And that presence is currently, and perhaps forever, out of reach. The technology to create a mobile platform that can withstand the heat, pressure, and corrosion for months or years does not exist. Any power source would have to function in that hellish heat without failing. Any moving part would have to be engineered from materials we have not yet invented. Venus, shining so brightly in our dawn and dusk skies, is a stark reminder that some frontiers are not about distance, they are about environment. The surface of Venus is a planetary pressure cooker, a realm where our ambition to explore meets the absolute, unforgiving limits of engineering and material science, keeping its most ancient geological secrets permanently under lock and a crushing, acidic seal. Venus teaches us that some worlds are sealed by pressure and poison, but the cosmos has prisons forged from pure force. A magnetar is a neutron star that took a wrong turn into the realm of the absurd. It possesses a magnetic field so powerful it redefines the word intense. While a typical pulsar's field is already trillions of times stronger than Earth's, a magnetar's is another 1,000 times beyond that. We are talking about a field so concentrated it could wipe a credit card clean from halfway across the solar system. This is not just a powerful magnet, it is a fundamental force that warps reality at the subatomic level. In the space surrounding a magnetar, the magnetic field is so overwhelmingly strong that it distorts the very shape of atoms themselves. An atom, usually a neat little cloud of electrons orbiting a nucleus, is stretched into a long, thin cigar shape. Chemistry, the rules that govern how atoms bond to form molecules, simply ceases to function here. The magnetic force overwhelms the electromagnetic bonds that hold molecules together. This means that any known material, any spacecraft hull, any instrument, and any hypothetical astronaut would not just be crushed or melted, they would be disassembled. The field would pull electrons right off their atoms and then tear the nuclei apart, reducing everything to a stream of subatomic particles long before it ever reached the star's surface. The magnetar does not just sit there quietly either. Its crust, that crystalline lattice of iron under immense strain, is locked in a constant battle with the magnetic field trying to break out. This stress builds until the crust cracks in a cosmic event called a starquake. Think of an earthquake, but on a sphere of ultra-dense matter the size of a city, with energy scales that are almost meaningless. A single starquake can release more energy in a tenth of a second than our sun will emit in 100,000 years. This energy erupts as a titanic flare of gamma rays and X-rays. In 2004, a magnetar 50,000 light-years away, halfway across our galaxy, released a flare so powerful that, for a fraction of a second, it outshone the full moon. It actually ionized Earth's upper atmosphere, disrupting radio communications. If such a starquake happened within 10 light-years of us, it could potentially strip our planet's ozone layer, triggering a mass extinction. This makes the space around a magnetar a dynamic and violently unpredictable kill zone. It is not merely a dangerous place. It is a region where the laws of physics that allow matter to exist are temporarily suspended by an unthinkable force. To send a probe would be an exercise in cosmic futility. Even if you could shield it from the constant bath of X-rays, even if you could harden it against the heat, the magnetic field itself would atomize it. There is no material science, no theoretical engineering that could withstand a force that twists the building blocks of matter into useless shapes. The magnetar's immediate environment is therefore a definitive and permanent no-go zone. It is a storm of pure magnetism, a place where the universe demonstrates a force so absolute that it forbids not just life, but the very integrity of matter itself. That magnetic storm of a magnetar is a force we can at least detect, but the universe's true ruler is a silent, intangible ghost. Every galaxy, including our own Milky Way, is not an island of stars floating in empty space. It is the glowing tip of a cosmic iceberg embedded in an immense spherical shroud of something we cannot see, touch, or comprehend. This is the dark matter halo. It is the dominant component of the universe, outweighing all the stars, gas, and planets by a factor of about 5 to 1. Yet, it is a presence defined entirely by its absence. Dark matter does not emit, absorb, or reflect any form of light. It is completely transparent, utterly intangible. It does not form atoms, molecules, or any of the structures we recognize. It does not clump into stars or planets. It passes through normal matter and through itself as if it were not even there. A spacecraft could fly directly through the densest cloud of dark matter in the galaxy, and the crew would feel nothing, see nothing, and their instruments would register no impact, no friction, no heat. It is a cosmic phantom, detectable only by the one force it cannot hide, gravity. We know the halo is there because we can see its ghostly hand gripping the galaxy. Stars on the outer edges of spiral galaxies orbit far too quickly. If only the visible mass of stars and gas were pulling on them, they should be drifting slowly like planets in the distant solar system. Instead, they whip around at speeds that should fling them out into intergalactic space. something invisible with immense mass must be holding them in place. That something is the dark matter halo, a vast, diffuse sphere that extends far beyond the last visible star, its gravitational pull acting as an invisible anchor for the entire galactic structure. We can even map its rough distribution, like a blind person feeling the shape of a statue, by watching how its gravity bends the light from more distant galaxies, a phenomenon called gravitational lensing. These maps reveal a cosmic web of dark matter, with galaxies forming at the densest knots in the web, but this is where our knowledge hits a permanent wall. We are exploring a shadow. We can trace the outline of the halo by the way it distorts the things around it, but we have no idea what casts that shadow. Is it a sea of exotic, undiscovered particles, trillions of which might be streaming through your body every second without a single interaction? Could it be primordial black holes from the dawn of time? Or is it a sign that our understanding of gravity itself is incomplete on cosmic scales? We simply do not know. The dark matter halo is thus the ultimate forbidden region, not because it is dangerous or distant, but because it is made of something that, by its very nature, refuses to interact with our reality in any way except a gentle, universal tug. We are swimming in an ocean of it, bound by its gravity, yet we are forever separate, able only to measure the ripples it leaves on the surface of the luminous world. To directly explore dark matter is a paradox, like trying to catch the wind with a net made of air. These cosmic phantoms of dark matter define the shape of the cosmos, yet they are not the only ghosts in the machine. Some objects are not quite stars, not quite planets, but something hauntingly in between. Brown dwarfs are the failed stars of the universe, cosmic underachievers that never gathered enough mass to ignite the sustained hydrogen fusion that makes a true star shine. They are embers cooling slowly in the dark, and their deep interiors are realms of strange and violent weather, forever hidden from our sight. Imagine an object dozens of times more massive than Jupiter, yet not massive enough to become a sun. It forms from a collapsing cloud of gas, it heats up, it may even flicker with brief deuterium fusion in its youth, but then the fire goes out. What is left is a layered world of escalating pressure and exotic states of matter. The outer atmosphere is a churning, turbulent blanket of hydrogen and helium, laced with clouds not of water, but of vaporized metals and minerals. In the cooler brown dwarfs, astronomers have found evidence for clouds of molten iron and silicate droplets, essentially raining liquid metal and hot sand. These storms rage in perpetual twilight, lit only by the dull, deep red glow of the object's residual heat. But the atmosphere is just a veil. Beneath it, the pressure climbs so high that the gas no longer behaves like a gas. It becomes degenerate matter, a state where electrons are squeezed so tightly they resist further compression, not through heat but through quantum mechanical pressure. This is the same physics that supports white dwarf stars, but here it forms a vast, hot ocean beneath the clouds. Deeper still, the pressures might force hydrogen into a strange, liquid metallic state, similar to the interior of Jupiter but on a grander, hotter scale. Some models even suggest that at the very core, under millions of times Earth's atmospheric pressure, helium might rain downward through the liquid metallic hydrogen, or that layers of different degenerate materials might settle like the strata of a bizarre planetary onion. We can model these layers with supercomputers, and we can study the faint infrared glow and spectra of brown dwarf atmospheres from afar. But to truly understand their internal dynamics, to map where the exotic rain ends and the degenerate ocean begins, we would need to see inside. And that is an impossibility. Their atmospheres are deep, opaque, and violently dynamic. Any probe attempting to descend would face a crushing combination of high gravity, extreme heat, and pressures that would destroy any known vessel long before it transmitted useful data. Even our best atmospheric studies are like trying to deduce the structure of a hurricane by only examining the color of the clouds at its very top. Brown dwarfs represent a critical missing link in our cosmic family tree, the poorly understood bridge between giant planets and true stars. Thousands of them likely drift through our galactic neighborhood, many solitary, many orbiting distant stars. Each one is a locked laboratory of extreme physics, a world where matter exists in states we can only simulate in equations. Their interiors are not just hidden, they are actively shielded by the very processes that make them what they are. They are the universe's abandoned furnaces, cooling secrets into the dark, their inner workings a permanent mystery sealed under layers of degenerate gas and storms of molten stone. Our own galactic center holds a silent monster, Sagittarius, a star. This supermassive black hole, with a mass 4 million times that of our Sun, presents a paradox of scale. Its event horizon is not a tiny point of destruction, but a vast sphere of darkness millions of kilometers across. You could fit our entire solar system comfortably inside that boundary. This immense size changes the rules of the plunge. Unlike a small, stellar black hole where tidal forces would shred you apart long before you reached the horizon, crossing the threshold of Sagittarius, a star, might be, at first, a strangely gentle experience. The pull of gravity is so spread out over such a vast area that the difference in force between your head and your feet would be negligible. You could, in theory, cross the point of no return without even noticing it, a silent passage into a new set of physical laws. But this physical accessibility is the ultimate cosmic trick. While you might cross without being spaghettified immediately, your connection to the universe you left behind is severed in a different, more profound way. As you approach the horizon, the immense gravity warps time itself. From the perspective of an outside observer watching you fall, your clock would appear to slow to a crawl. You would seem to freeze, your image dimming and reddening as the light struggling to escape is stretched to longer wavelengths. To them, you would never actually cross. You would become a fading fossil, eternally etched on the edge of the shadow. For you, however, time would pass normally. You would cross the horizon and continue inward, but any signal you tried to send back, any final message, would be trapped. The light from your transmitter would be stretched into wavelengths so long, so low in energy, that they would be indistinguishable from the background whisper of the universe. Your entire experience beyond that line, your observations of the warped space within, would be yours alone, a story forever locked inside the black hole's vault. This is why the stunning image from the Event Horizon Telescope is so significant and yet so limited. That glowing ring of light is not the event horizon itself. It is the photon ring, the last orbit where light can still loop precariously before falling in. The dark shadow at the center is the silhouette of the event horizon against this glowing background. It is a picture of the absence of light, a map of the point where our information ends. We have taken a photograph of a one-way door. Sagittarius, a star, for all its colossal size, is not a destination. It is the ultimate boundary, a spherical wall in spacetime where the universe politely, but absolutely, ends the conversation. Any data, any history, any record of what lies beyond is swallowed, leaving us on the outside with only a shadow and a profound, permanent silence. The shadow of our galaxy's central black hole is a monument to isolation, but the universe's grandest structure is a ghost of connection. This is the cosmic web, a vast, delicate architecture of threads and nodes that holds the entire visible cosmos. Galaxies are not scattered randomly. They are strung like glittering beads along immense, invisible filaments that stretch for hundreds of millions of light years. These filaments are the universe's scaffolding, the superhighways along which matter flowed in the aftermath of the Big Bang. They are made of two things we cannot easily see: the mysterious dark matter that provides the gravitational skeleton, and a thin, searing hot gas known as the warm-hot intergalactic medium. This gas is the majority of the normal matter in the universe, but it is so diffuse it had been nearly invisible to us until recently. the density inside one of these cosmic filaments is almost beyond comprehension in the emptiest sense. We are talking about a handful of atoms, maybe 5 or 10, in a volume of space the size of a typical office cubicle. This is a vacuum far more perfect than anything we can create in our most advanced laboratories on Earth. It is emptier than the space between stars within our own galaxy. So what would it mean to explore such a place? Imagine piloting a spacecraft into the heart of a cosmic filament. You would not see a glowing tunnel or a river of light. Your viewports would show only the same featureless black of deep space. You would not feel a gentle pull or sense of motion along a current. The gravitational tug of the filament is far too weak, spread across such an immense volume, for your instruments to register. You would be, for all intents and purposes, lost in a void. There would be no landmarks, no stars to navigate by, because the stars are all concentrated in the galaxies that cling to the filament's edges like towns along a remote highway. You would be adrift on the highway itself, a stretch of road so wide and empty you could not see the towns on either side. The structure of the filament only becomes real when you step back, far back. Astronomers map it by painstakingly plotting the three-dimensional positions of millions of galaxies across the sky. Only then does the pattern emerge from the noise, a statistical ghost of spider silk on the scale of the observable universe. This gas, this warm, hot intergalactic medium, is so hot that it glows not in visible light but in high-energy X-rays. Our only way to detect it is with space telescopes that can see this faint, diffuse X-ray emission, a whisper of heat from the spaces between everything. So the cosmic filament is a forbidden region of a profoundly subtle kind. It is a structure that defines the shape of everything we see, yet it is impossible to point to and say, there it is. You cannot visit it because from within it does not exist as a place. It is a relationship between distant points, a pattern written in the collective positions of galaxies separated by unimaginable gulfs of nothing. To travel its length is to misunderstand its nature. The filament is not a tunnel through space, it is space itself, shaped by gravity on the grandest possible scale. It is a cosmic highway that is everywhere and nowhere, a map that can only be read from a vantage point far outside the territory it describes. This final frontier is not a place we could ever travel to, for it exists at the very beginning of time. The ultimate forbidden region is the singularity of the Big Bang itself. This is not a location in space you could point a telescope toward. It is a moment, an instant of infinite density and temperature from which our entire cosmos, all of space and time, erupted. It is the original locked door, the one that started this entire list. At this point, the equations of general relativity, which describe the universe so beautifully from that moment onward, scream in protest. They return a result of infinity, a sign that our understanding has hit a wall. Gravity becomes so strong and the universe so small that the smooth fabric of spacetime described by Einstein dissolves into the chaotic, probabilistic froth of the quantum realm. To comprehend what happened at time zero, we would need a theory of quantum gravity, a set of laws that unifies the very large and the very small. We do not have that theory yet. Without it, the moment of creation is a mathematical mystery, a blank page at the beginning of the cosmic storybook. We can trace the history of the universe back to a tiny fraction of a second after this event, to the inflationary epoch we discussed. We have the cosmic microwave background as a baby picture from 380,000 years after, but the singularity itself, the true beginning, is permanently obscured. It is a boundary in time, not space. You cannot go back to it because before it there was no before. Time, as we understand it, did not exist. There is no older data to retrieve, no light from an earlier moment to analyze. It is the ultimate event horizon in the past, separating the knowable universe from the absolute unknowable. Every other region we have explored, from black holes to the quantum foam, presents a barrier we might one day, in theory, understand or even circumvent with new physics or unimaginable technology. But the initial singularity is different. It is the foundation. Exploring it would mean having a perspective outside of time and space, a vantage point that the universe itself, by its very definition, does not permit. It is the one secret the cosmos is structured to keep forever, the first and final word on all the places we can never go. 25 doors, each locked by a different law of reality. From the silent singularity of a black hole to the ghostly filaments of the cosmic web, our journey has mapped the permanent frontiers of the knowable. These are not places waiting for a faster ship or a better telescope. They are sealed by the universe's own architecture, by crushing gravity, by the speed of light, by the irreversible flow of time itself. We stand on our tiny, fragile world, gazing out at a cosmos that is overwhelmingly, beautifully forbidden. Yet this is not a story of defeat, but of definition. These boundaries tell us what the universe is by showing us what it is not. They frame the stage upon which our story can unfold. The fact that so much is hidden is not a flaw, it is a feature. It is the blank space on the map that calls to the explorer, the unanswered question that fuels the scientist. Every mystery we have explored, from the dark heart of Jupiter to the echo of inflation, is a puzzle that drives our imagination and sharpens our intellect. It pushes us to build better instruments, to conceive wilder theories, to peer just a little deeper into the shadows. So now we turn the question to you. Which of these permanently forbidden realms captures your imagination the most? Does the lightless ocean of Europa call to you, or the mathematical scream of a singularity? Do you dream of what strange chemistry might unfold on a rogue planet, or what reality looks like within the quantum foam? Share your thoughts in the comments below. Tell us which cosmic lock you wish we could pick, and what you theorize lies behind it. If you enjoyed this journey to the edges of impossibility, be sure to subscribe for more explorations into the universe's greatest mysteries. And never stop looking up at that starry sky, knowing that its greatest secrets are the ones it was designed to keep.